Welcome to my discussion for this week. Today, I'll be covering the what, how, and why of decorators in the Python programming language. To get started, we're going to be covering function decorators today, and function decorators are a feature of the Python programming language that result from the nature of how functions are variables in the language and are really able to leverage that fact to great effect. According to the CodeShip's January 2014 article, A Guide to Python's Function Decorators, in the Python programming language, functions can be assigned up variables and passed around as any other data in the language. Due to this trait, we can rename functions by assigning them to a different variable than the name they were originally defined with, or even pass them as parameters to other functions. An additional trait of Python that's important before we go into what function decorators are is that Python, as CodeShip highlighted, has the ability of functions to access the outer scope with read-only access. This means that when we define a function, any definitions that have been made in the same scope where the function is defined are available to the newly defined function. So why are these two traits important? So let's explain what a decorator is. According to CodeShip, a decorator is, in essence, a wrapper around a Python function. The decorator is a higher order function that accepts the original function as an argument, and then performs some functionality before, after, or before and after the function's call, and then returns this new function with the added functionality as a new function. The original function maintains its functionality. However, the additional functionality from the wrapper function has been added, and it is, to quote CodeShip, thus decorated. But so what? Why is this worth discussing even? We know what function decorators are now, but why do we care when it sounds so cumbersome to define and call them? According to CodeShip, Python actually has a far easier way to call decorators than to reassign the function definition, as you would originally have to. And that is by using the @decorator syntax. According to CodeShip, we can define our decorator by defining a higher order function, such as myDecorator, that accepts one positional argument for the function that is being decorated. We can then define an inner function within this decorator that accepts the same arguments as the originally decorated function. In this wrapper function that we define, we can then call the outer scope function argument, which will refer to the original function, and pass in the data from our wrapper function that's representing the data passed into the original function. By making this call, we're ensuring that the functionality is the same as the original function. However, in this wrapper function, we can then define any additional statements that we want before or after calling the original function with the original data. Once we've defined our decorator, we can decorate our original function by adding the @myDecorator, or whatever we named the decorator, one line before and at the same indentation as our function definition. By doing so, Python will automatically call the decorator on the function before it's called by the language. So why might we want to actually use these decorators? Well, there's a couple of examples that immediately came to my mind when I was learning about these. One of those is pre-processing. You could use the decorator to change the format of some of the input arguments to either align them better with the data you're expecting, or maybe validate some information about them. You could use them for post-processing, where you would modify the result of the method call to maybe format it or change something about it. Another real big one that I immediately came to mind is cleanup. So for example, if you're using maybe a transactional database such as MySQL, in your function errors, you might want to roll back all of the statements from your function call. So what you could do is you could define a decorator that wraps your function in a transaction and if you catch an exception from your function, you could roll back the transaction and then rethrow the error. This would be a lot quicker than having to write that functionality into all of your methods, because you could just add a single decorator to your functions that need to have this transaction rollback on error. But you can also write a decorator that cleans up maybe I/O operations or any sort of thing like that might need cleanup in the exception, if there's ever an exception. The final example that I also thought of was logging, and this is where you might want to create a decorator that logs some of the input or output of the function when it's called. And just having a decorator would be useful because you could just slap that onto any function without changing the function itself, and that could be good for debugging or tracking down issues. Of course, these are just a few of the examples that I thought of, but these are hardly the only scenarios you can use decorators in, and they're an extremely powerful feature of the language that it's always good to be aware of, since you can do some really cool things with them. In conclusion, today we've covered what function decorators are, the basics of how to define them, how to use Python's syntax for decorators, as well as some of the useful scenarios that you can use decorators in. Hopefully you can find some useful places to use decorators on your own. Thank you for listening.